Welcome to our video on USub using definite integration. We've done USub before, so that's not so bad. So now we're going to be doing it with bounds. So real quick, as you can see, here was the USub type of deal here, because you have a function inside of a function, which also is the derivative on the outside, which makes it USub very easy to do. The big thing I want you to notice here is when we start changing it to U, du, that was a very rude interruption. I'm going to change it from x's to u's, my bounds change too, and that's the big part. So a changes into whatever g of a is, and b changes into whatever g of b is. We need to make sure we change those bounds. That's a huge deal, and that's actually a pretty common mistake for these. So let's go ahead and look at numero uno. So for this first example, if I'm trying to find the antiderivative, I can't unless I use USub. So I'm going to let u equal 3 minus 5x. I don't want to do the squared part because that's not going to work out for me. Okay, this is what I would call a baby USub. Okay, the reason it's a baby USub is because nothing's going to end up canceling out. All I'm going to be doing is getting rid of the x's. So du is going to equal negative 5 dx. So negative 1/5 du is equal to dx. So I'm going to do a little bit of work here. I'm going to ignore the bounds for right now, and then I'll show you how to finish that up. So we're going to integrate. That dx becomes a negative 1/5. If you don't mind, I'm going to put that out in front just because it's much easier that way, less things to worry about. And this is going to become 1 over u squared du. Okay. Now, I mentioned that my bounds change. They do change. I have to plug in a 1 and a 2. So I'm going to do u1. Plug in a 1, so I'm going to get 3 minus 5, which is negative 2. So now my lower bound changes from 1 to negative 2 because I'm plugging it back into my original u statement. And then u of 2 is going to be 3 minus 5 times 2, which is 10, which is negative 7. So I'm going to get negative 7. So these are my new bounds. If you notice, my lower bound is actually a larger number. You're totally allowed to flip it. Okay, so you are allowed to flip this answer, the 2's and the 7's, or you could just keep it. It does not matter. Okay, if you do flip the negative 2 and the 7, you have to change that negative 1/5 out in front to a positive 1/5. I'm just going to leave it because it really doesn't matter so much. I'm just going to rewrite this as negative 1/5, negative 2 to negative 7, u to the negative 2 du. Now, I no longer have to change it back, which is super nice for the definite integration of USub. I do not need to change it back. I can just leave everything in terms of u's because I'm going to end up getting a number anyway. So the antiderivative of that is going to be u to the negative 1. Divide by that, so it's going to turn into a negative u to the negative 1 times the negative 1/5 out in front, evaluating it from negative 2 to negative 7. Just to clean this up a little bit, it's going to become 1/5 times 1 over u from negative 7 on top, negative 2 on the bottom. I'm just going to go ahead and use my cheat sheet right here right in front of me to make my life a little bit easier with figuring out the answer, because you can always do the arithmetic yourself. So you're going to get 1/5 times 1 over negative 7 minus 1 over negative 2. What's going to end up happening here is you're going to get an answer of, it looks like, you're going to get 1/5 times 5/14, which is going to give you 1/14. Arithmetic, I'm going through that really fast because you are able to do that on your own. Next one here. So as we integrate from 0 to 2, here's our function right here. Again, we're going to need to do some USub in order to knock out this x dx. Okay, so I'm going to let u equal 1 plus 2x squared. There is no formula that I can use to find the antiderivative, so I do need to plug this into a USub. So u is going to equal, du, if I take the derivative, is going to give me 4x dx. So 1/4 du is going to equal x dx, which is perfect. I have an x dx I need to get rid of. So I'm going to go 1/4 integral of 1 over root u x dx turns into a du. And then I put the 1/4 right out in front. Let's do my bounds. So if I plug in a 0, I'm going to get 1. If I plug in a 2 into my u, I'm going to get 9. So that's going to be a 1 on the bottom, 9 on top. And now I'm ready to go ahead and rewrite this so I can find the antiderivative with no issues here. Okay, so the antiderivative is going to be 2u to the 1/2. The 1/4 in front, evaluate that from 1 to 9. This is really just going to change into a 1/2 right here. Square root of 9 minus square root of 1, which is going to give me an answer of 1, right? Because you're going to get 3 minus 1, which is 2. 1/2 times 2 is 1. I'll explain their answer as well. And that's just u-sub with definite integration, okay? I'm going fast through the arithmetic. Hopefully we're understanding here about the u-sub, about what to pick out. Now, we've already done a video on u-sub, so that's why I am going a little bit quicker on that. Big thing here, make sure you change those bounds. I know I have more problems. Oh, here they are. All right, let's get triggy with it. Let's get some trig problems in here. So this is a baby u-sub because I don't have to cancel out any other function. So I'm going to let u equal 3x. So du is equal to 3dx. So 1/3 du is equal to dx. So dx is going to change into that 1/3. So 1/3 sine of u du, which is an easy antiderivative. Now let's go ahead and plug in my pi over 12. If I plug in a pi over 12, 3 times pi over 12 is pi over 4. So the bottom bound is pi over 4. And the top bound, pi over 9, is going to turn into, if I plug that in, pi over 3. Okay? So now antiderivative of sine of u is going to be negative cosine, remember that, negative cosine of u. I still have the 1/3 out in front. Evaluating this, pi over 3, pi over 4, and boom. I'm going to pull that negative out to that 1/3 part. So I'm going to get cosine of pi over 3 minus cosine of pi over 4. You need to know these values, okay? Super duper important. So cosine of pi over 3 is going to turn into, well, it's negative 1/3. Cosine of pi over 3 is going to be 1/2, right? 1/2. So it's 1/2 minus cosine of pi over 4 is root 2 over 2. You can make this into one fraction right now. So this is going to be negative 1/3 times 1 minus root 2 all over 2. So this is going to give me negative 1 plus root 2 all over 6. Okay. And that's the answer. Just cleaned up as much as it can be. Next example, a little bit more trig here. Tricky part is going to be getting rid of this cosine x dx. So in order to get rid of this cosine x dx, I have to let u equal sine of x. I don't let u equal sine of the third because it's not going to knock out a cosine x dx. It's actually going to give me more issues. Or if I let u equal cosine, I'm not going to be able to knock out this sine cubed x dx. So let u equal sine of x so that du equals cosine of x dx. Pretty straightforward. So I'm going to integrate u to the third du. Yeah, that's totally awesome. Now let's go ahead and plug in my values. So u of 0 is going to be sine of 0, which is 0. U of pi over 6, which is going to be sine of pi over 6. Again, you need to know that as 1/2. So I'm going to go from 0 to 1/2. Very straightforward from here. You're going to get 1/4 u to the 4th. Evaluate that from 0 to 1/2. What is super nice about this is since I have the 0, if I plug that in, it's just going to go to 0. So I'm left with 1/4 1/2 to the 4th minus 0 to the 4th, which is going to give me 1/4 times 1 over 16, which is 1 over 64, or u sub. All right, last problem here. A little bit of a word problem. A little application of this stuff is find the area bounded by the graph of y equals x square root of x squared plus 1 on this interval from 0 to 2. So I'm trying to find the area of, I'll shade it purple. And if you are getting a little lost in this video, if this is going a little too fast, you're going to need to brush up on your u sub as well. So I do have a u sub video in the archives that you can go ahead and find. Okay, so what this is saying is I need to integrate from 0 to 2, and my integrand is going to be this function right here, x square root of x squared plus 1 dx. Okay, so easy thing to u sub here. I really want to get rid of this x dx, and I can do that because I know the derivative of x squared plus 1 is going to give me some type of x dx. So du is going to equal 2x dx. So half of this du equals x dx. Okay, so now this x dx goes away, it turns into a 1/2 integral from u to the 1/2. I'll just put that as an exponent. Du, if I plug in a 0, I'm going to get 1. If I plug in a 2, I'm going to get 2 squared plus 1 is 5. So we go from 1 to 5. Answer here not going to be too pretty, but let's just go with it. So we're going to get 1/2. Antiderivative of that is going to be u to the 3/2. We divide by that, so it's going to become 2/3 times that. Evaluate that from 5 to 1. Okay. Just going to clean this up a little bit because 1/2 times 2/3 is going to turn into 1/3. And I'm going to get 5 to the 3/2 minus 1 to the 3/2. And really, at this point, you're done, but this might not be an answer that you see for multiple choice. This is going to be 1/3. This is the same thing as the cubed root of 5. Sorry, not cubed root, square root of 5 cubed minus 1. It could look like that. Or if we simplify this just a little bit further, this is the same thing as 5 root 5, because we can take out, since it's 5 is being cubed, I can take out a 5 squared out to the outside, become 5, and there's still 5 on the inside. This is probably how it's going to look for multiple choice. So just kind of be aware that going from here, 5 to the 3/2 is the same thing as 5 root 5. Okay, and then 1 to the anything is just going to turn into 1. And that is going to finish up our video here on u sub with definite integration.